In today's video, we're going to cover section 6.1 called Angle Measure. So the first thing I want to look at today is I drew down the unit circle here. And notice that we start at 0 degrees over on the right. We go counterclockwise on this. So then we have pi over 2 or 90 degrees up at the top, pi or 180 degrees over on the left, and 3 pi over 2 or 270 degrees over on the bottom. And if we go all the way around, we reach back to 360 degrees or 2 pi. But really, what does this tell us? If we look over here on the left, this tells us that pi and 180 degrees are the same thing. So that gives us 180 degrees is equal to pi radians. Those two values are equivalent. So what that tells us is that if we want to convert from degrees to radians, we multiply by essentially 1, because pi radians is equal to 180 degrees. So we multiply by pi over 180. All right, we're dividing by the degrees, and then we're multiplying by the radians. So if we're doing some dimensional analysis here, or converting units, we are dividing by the degrees and then multiplying by the radians. In a similar way, if we want to convert from radians to degrees, we multiply by 180 over pi, right? We divide by the radians and we multiply by the degrees. So that'll lead us to our first example here, and that is to convert 75 degrees into radians. If we are converting degrees into radians, we start with 75 degrees here, and we multiply by pi radians over 180 degrees, and we get 75 pi over 180. We can reduce 75 over 180 by dividing by 15 on the numerator and denominator. And when we do that, we get 5 pi over 12. Similarly, we can convert pi over 10 into degrees. All right, so we have pi over 10 radians. I should mark radians here. We're going to convert that into degrees. So to do that, we start with pi over 10, and we multiply by 180 degrees over pi radians. This becomes 180 pi over 10 pi. 180 over 10 is 18, and the pi's cancel, so we get 18 degrees. Example 3 here will be to find some coterminal angles of, and we have two parts. Part A is 215 degrees, and part B is 5 pi over 12. All right, this is a little different than, sorry, I was off the page, or off the screen. So this is a little different than what we've been doing. So coterminal angle is a new terminology. That just means that it ends at the same spot on the circle. So all the way around the circle is 360 degrees. So if we want a coterminal angle of 215 degrees, we can take 215 degrees and add 360 degrees to that, because that means we'll end up at the same spot on our circle. So 575 degrees, that angle, 575, is the same as 215. So they are coterminal. They point in the same direction. Okay? Similarly to adding 360, we could have subtracted 360 degrees. And that should be negative 145 degrees. So if we go 145 degrees in the clockwise direction, which is negative, then that would be the same as going 215 degrees in the counterclockwise or positive direction around the circle. We could, of course, continue adding 360 or subtracting 360 to find more coterminal angles, but here are two such angles. We have a very similar solution for part B here, except we're starting with 5 pi over 12 radians, and if we have a pi in there, we're probably talking about radians unless for some reason it's designated otherwise. But here we would be discussing radians. So if we're going to find a coterminal angle of 5 pi over 12, instead of adding 360 degrees, since we're doing radians, we need to add the equivalent of that when going around the circle entirely, when we're discussing radians, is 2 pi. So we're going to add and subtract 2 pi now. So 5 pi over 12 plus 2 pi, which I want to rewrite as 5 pi over 12 plus 24 pi over 12. So that we have a common denominator. This gives us 29 pi over 12. So here is one coterminal angle. And similarly, we could have 5 pi over 12 minus 2 pi. So 5 minus 24 is a negative 19. We get negative 19 pi over 12. And we've now found two coterminal angles to 5 pi over 12. All in radians. Again, we can continue to add or subtract 2 pi from these values to find more coterminal angles for 5 pi over 12. So if you need to find more, you can. There is one more question that we want to do from this section, that I want to cover from this section. And so that is example 4. Here. Find the length S of the circular arc I'll draw a picture to explain what I mean. In this instance, if we have a radius of a circle and we have a angle measure here, then where the arc, the length of the arc that we're talking about is this piece right here. So it's that S. And in particular in this question, we want to know this, where R is equal to 3 and theta is equal to 130 degrees. The formula for this is in your book, but it is S is equal to R theta, so it's just a product of the radius and the angle. But there's one key note here, and that is that theta must be in radians for this formula. So the first thing we want to do is convert our degrees to radians. So if we're converting degrees to radians, we multiply by pi radians and we divide by 180 degrees. So this is 130 over 180. That is the same as 13 over 18. So this is 13 pi over 18. And this is in radians. That is our angle measure in radians. Then we use our formula to find S. So S is equal to R times theta. R is 3, theta was 13 pi over 18. So our measure of our angle length here is going to be 39 pi over 18. And I didn't write units here, but the units will be whatever the units of length that the radius will be in. So whatever units were there would be the units on this S. And that's it for section 6.1.